there is a concept of backtracking. Okay. There is a concept of backtracking. Now, what is this backtracking? I have already discussed in our class. Now, once you go to one depth of a tree, right, you need to check for another node. Now, for example, while coming backing to this tree, if there is one more node here, right, you have to go to that and you have to again come back, right? After that, you are going to come back to the root node. And if there are any nodes to the right of the root node, you are going to go back to that node, right? And that completes our DFS because this is a depth first search. That coming back is called as a backtracking. So since we are using backtracking, we are using the concept of recursion, because in recursion, you know that we have seen a factorial of a number example, and also the recursion is used in merge sort, right? We have seen also in quick sort. So we're using the same concept here. So this code is much simple. Now you can see in line number 26, I have created a function DFS, right? And what am I expecting? I'm expecting two things. One is called as a starter, right? And I'm defaultly giving the parameter visited as none. Just understand the code, okay? At the moment, visited is none, right? Now let's go to the function code. Right? What am I giving? You see here line number 37. I'm saying the DFS transversal is going to be what? Is going to be DFS of 0. That means what? I am starting at the first node of 0. Okay. Now start is going to be 0. Start is going to be 0. Now let's go to the next line of code. If visited is none. At the moment visited is none, true. So what we're going to do? Instead of none, I put a list, right? Instead of none, it is going to be a list, right? Now, what is the next line of code? Visited.append start. What is start? Start is 0. So I am appending 0 in the visited. Now let's check the for loop. For neighbor in the graph of 0. What are the neighbors of 0? Let's go back to the graph. So 1 and 2. Right? So let's go back to our code. The neighbors of 0 is going to be 1 and 2. Right. Now, the next line checks if neighbor not in visited. What is the neighbor? 1. At the moment, we are running for 1. Is 1 in visited? No, it is not visited. Right? Since 1 is not visited, I am running DFS of neighbor. Again, this time I am doing recursion. DFS of neighbor. What is neighbor? Neighbor is 1. And what is visited? Visited at the moment it is 0. So I'm calling a function within a function. Now this time you're going to check if condition. This time we're going to check if condition. Now since if is not none, right? Since not none, it is 0 at the moment, right? So you're going to skip this code. You're going to skip this code and you're going to say visited.append. This time it's going to be what? This time it's going to be 1. So this time you're going to append 1. Okay. Now you're going to check the neighbors of 1. This time it's not going to be 0. It is going to be 1. What are the neighbors of 1? The neighbors of 1 are 0 and 3. So let me write down the neighbors are 0 and 3. Okay. First, if 0 not in visited. So since 0 is in visited, you are going to skip it. Right. Now check for 3. Now is 3 in visited? Is 3 in visited? No, 3 is not in visited. So you're going to run back the recursion back. Okay, now this time it's going to be DFS of, this time it's going to be 3 and visited. What is visited? 0 and 1. Okay. So this time we're running back the recursion with 3 and visited 0 and 1. Now we're going to append the 3 to the visited. You're going to append the 3 to the visited. And this time you're going to check the neighbors of 3. What are the neighbors of 3? 1 and 2. Now, the neighbors of the graph of 3 is going to be 1 and 2. You're going to run the first time for 1 and you're going to check whether 1 is in the visitor or not. Since 1 is in the visitor, you're going to skip it, right? And check for the next one, which is 2. Is 2 in visited? No, 2 is not in visited. So what you're going to do? You're going to run back the recursion again. DFS with 2, right? And the visited. What is a visited? Visited is 0, 1 and 3. Right. So you're going to run back the recursion again with 2. Now this time what happens? Instead of 3, it's going to be 2, right? And you're going to append the 2 to the visited. So the visited becomes 0, 1, 3 and 2. Now all the recursion is done. So now we're going to backtrack to DFS of 3. This is also done. Now we're going to backtrack to BFS of 1. Okay, so this is done. So let us check the output with the expected what we got. So DFS is going to be, the graph is going to be 0, right? 0, 1, 3 and 2.